Hello, 8th grade. Okay, so we're going to be reviewing the two rules that we learned in the past 2 weeks, the product rule and the quotient rule. So looking at this problem right here, which rule do you think we're going to be using, product or quotient? Yeah, we're going to be using the product rule because we are multiplying, and product means the answer to a multiplication problem. All right, so it says expand. So first I'm going to expand my exponents. If I have -6 to the second power, that's the same as what? -6 squared. So I'm going to multiply it 2 times. And then I have 5 more -6s, making sure that you're expanding that negative with the 6 because there are parentheses. Now I'm going to count because I need to simplify. So I need to know how many times I have this -6 written out. 1, 2, 3, 4, 5, 6, 7. So what is my exponent going to be when I simplify? Yes, my exponent will be 7. So I'll have -6 to the 7th power. Remember, we're thinking about, okay, what's the relationship between these two numbers and this number? So I'm going to keep this on the board for when we do the next problem. So -6 to the 7th power. All right, so then our next one is pretty much identical. We just have different base and different exponents. So you have 5 to the 6th power times 5 to the 4th. Is our base the same? Yes, it is. What operation are we doing between these two terms? Right, multiplication. So it says expand, so I'm going to expand it out. How many times do I expand out this first 5? 6 times. So I'll have 5 times 5 times 5 times 5 times 5 times 5. And then how many times will I expand out this second 5? Right, 4 more times. So I'll have 1, 2, 3, 4. Now I simplify. What will my exponent be when I simplify? We can count to figure out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My exponent will be 5 to the 10th power. All right, so now I'm going to use these two problems to write my rule. So here, that's 10. I have two -6s and 5 -6s. I ended up with 7. Here I had 6 and 4 and ended up with 10. So I need to add my exponents in order to simplify. So under write the rule, when you are multiplying exponents, with the same base, then in really big letters, write add the exponents. All right. So now let's go on to the quotient rule. If it's called the quotient rule, what operation do you think it's applied or we're going to be using? Yes, division, because quotient is the answer to a division problem. Our first problem is 8 to the 6th power over 8 squared. This is telling me to expand it first. So when I have 8 to the 6th power, how many 8s will I have as my numerator? I will have 6. And then how many 8s will I have as my denominator? I will have 2. So then I can go through crossing out. I have an 8 and an 8 here. I have an 8 and an 8 here. How many 8s am I left with? Yes, I'm left with 4. Are they in my numerator or denominator? They're in my numerator. So I can write it as 8 to the 4th power over 1, which is the same as 8 to the 4th. So 8 to the 6th power over 8 squared equals 8 to the 4th power. Now let's try our second one. For the second one, we have 8 to the 10th power over 8. Again, it's telling me to expand it. So I have 8 10 eighths on top. 4, 5, 6, 7, 8. And then down here, I don't have an exponent. So how many eighths do I have on the bottom? Yeah, I just have 1. So you can write your exponent as 1, which means that I could only cross out 1. So how many eighths am I left with? Yeah, I'm left with 9 eighths. Are they in my numerator or in my denominator? They're in my numerator, so I can write it as 8 to the 9th power, and then we'll leave our denominator as 1, because when we cross these out, it equals 1, which is the same as 8 to the 9th power. All right, so now let's look at these again and try and figure out our rule. We have 8 to the 4th power up top and 8 to the 9th power down here. How do we get from 6 over 2 to 4? Right, when we're dividing with the same base, we subtract our exponents. So under write the rule, right, when you are dividing with the same base, subtract your exponents. Go ahead and finish the rest of this page independently. Good luck.